We are on the North Shore at 3 tables. You see the beach is totally deserted. We are watching waves. Now it's pretty calm. I see some waves coming there. The waves are coming at an approximately at 10 meters from each other. So that corresponds to a frequency of about 32 hertz. So if these waves were sound waves, then we would be listening to a fundamental C, which is the lowest pedal on a church organ. So that's what we are seeing in action. That's how the sound waves are as well. So they have the big crest, and they have tiny changes of pressure riding along the big changes of the pressure. And as you see, the waves are coming at us. So with the sound frequencies, that would correspond to the sound being in phase. That the waves come towards you instead of going away from you. So as you can see, the ocean waves are in phase as well. The only time ever when an ocean wave is not in phase, when there's a tsunami, and then before the big wave hits, the ocean level drops slowly, and then comes the big wave. And that happens on the scale of 6 hours. So it means that a tsunami, at least here, it's a single wave with a frequency of about 50 microhertz. So 50 millionth of a hertz. That's why it's so huge, because it has an extremely low frequency. Now we are listening to frequencies about 1 million times higher than that of a tsunami, and that's the big waves. Now the ocean is quieting, so you see that the waves are still coming, but they are not high. It means that their amplitude is slow. That corresponds to quiet music. And when you see the amplitude rising, like over there, there's a bigger wave, it means that it's loud, it's getting louder. And we can also hear it as the sound at the ocean waves. When there are bigger waves carrying bigger energy, the sound is much, much louder. Just another quiet, freezing winter day here in Hawaii.